Okay, so in this next part of 4.3, we're going to recap a lot of the factoring methods that we know. So first technique that we need to learn is when we're solving by factoring. So say we come up with something that looks like this, and I'm going to use the factors that I had on the previous page. So let's say if we have this, so x plus 3 times x minus 5, and you know that it's set equal to 0. So if we start off with that, we know that if the product is 0, that one or the other must be equal to 0. So the way it works is then we take each of these individual pieces. We can take the x plus 3 and set that equal to 0, or we could take the second piece and set it equal to 0. So that's how with the quadratics we end up with two answers. So that's what solving by factoring looks like. Very, very, very important that we have a 0 on one side, and then all the other stuff should be on the other side. So when we get our factors, we set each of the factors equal to 0, and then we would solve. Okay, so that's called the zero product property. They have that in the book. So example 2, we're going to look at a couple different methods here. The first technique that we are going to talk about, this is technique number 1. And that technique is to factor the GCF. So remember, GCF stands for greatest common factor. You want to do this every single time you factor. Take a look, 2 terms, 3 terms, however many terms you have. See if there's something that they all share, like a factor that they all have in common. So this first one is a good example. Over on the left-hand side, I have a 9y squared, and I have a 3y. 9 and 3 are both multiples of 3. Okay, so I know that my GCF is a 3, and then here I have 2 copies of y, and here I have 1 copy. So in common, they have 1 copy. So with it factoring out the GCF works is it's like undistributing. So it's like I take it out, and then in parentheses, you're going to have what's left over. So we're factoring out of 3y, which means first you take the 9y squared, and like I said, it's like you undistribute the 3y. So you divide by it. So if I take the 9y squared and divide out a 3y, I am left with a 3 and a y. And you could always double check by multiplying these back together. You would in fact get the 9y squared. And then plus, now here's a 3y. If I divide out a 3y, careful here, you're not left with 0, you're left with 1. So don't forget to write that. And also don't forget that you still have your 0 on the other side. Okay, so now the way this works, I technically have 2 separate factors right here. I'm going to set them both equal to 0 and solve. So I'm going to take the 3y, set it equal to 0. I'm also going to take the 3y plus 1, set it equal to 0. So now whatever algebra you need to do at this point to get the variable by itself. So this one, divide both sides by 3. Here the 3's will cancel, and then on the right-hand side, 0 divided by 3 is still 0. So that's one of my answers. Here I'm going to start by subtracting 1 from both sides. And then my second step would be to divide both sides by 3. So here the 3's will cancel, and I get negative 1/3 as my second solution. And you can always check these on your calculator. I'm going to run through the check, maybe with this next example. So this one right here, we're going to do the same technique. Let's identify whether or not we have a GCF. So start with numbers 5 and 20. They're both multiples of 5. So 5 would be part of our GCF. And then very similar to this one, here I have 2 copies of A, here I have 1. So they both have 1 copy in common. All right, so I will factor out the 5a. It's like undistributing, so you're going to leave in parentheses what would be left over, and then don't forget it is an equation. So if I take 5a squared and I divide out a 5a, I am left with a single copy of a, minus, and then if I take 20a and divide out a 5a, the a's will cancel, I'll be left with 4. Okay, so just the same as I did up here, same as I described here, I'm going to take each piece. So remember, this is technically 1 factor as well. So I'll set that one equal to 0, and then I'll take my second factor and set it equal to 0. So I'm just trying to get the variable by itself. So here, I would divide both sides by 5. So I end up with 0. Remember, 0 divided by anything is still 0. What you can't do is divide by 0. People mix those up all the time. All right, here add 4 to both sides, and we end up with a equals 4 as my second answer. So I'm going to show you guys how to do the calculator trick. I'll do it once, so rather than doing it over and over again, because once you guys see it once, hopefully, you can remember how to do it. So here's what it looks like. So we've done this before in different sections. You just start by storing in one of your values. Okay, so it's going to look like this. So we'll start with a 0. So you press the 0 first. You always hit the number first, then the variable. And then you'd hit Control, this blue button. and then this button for the storing, it's var, and then we'll store that in as a, since that's our variable. Now what you do is you just type this in, and we're just looking for a true false. So 5a squared minus 20a, we want to see if it does in fact equal 0, so go ahead and hit enter, and we get true, so that one works. So now we can plug this one in too. So now we'll take 4, store that in as a, we're replacing the 0 now. So now remember, you don't have to retype, just arrow up a few times until it's highlighted. If you hit enter once, it'll paste it, and then hit enter again, and it'll check. So those are both our answers. So you can always do a really quick true check. If you come up with any falses, maybe take a quick look at your algebra, see if you did anything wrong. Okay, now we are working up to these perfect squares, trinomials and binomials. So here's the way that these are going to work. These three-piece inequalities, if it's just an x squared like this, when you factor this down, you're trying to basically replicate the way foiling worked, except backwards. So you know that this term was part of the first, so that came from multiplying this times this. So the only way to get an x squared is to have an x here and an x here. So I know that x times x gave me an x squared. So now for this right here, I know when I multiplied them together, I got 9. So I know the product is supposed to be 9. And then I know when I add outside inside, I'm going to combine up and get a negative 6. So the product is supposed to be 9. The sum is supposed to be negative 6. So it's like we're trying to come up with those magic numbers that make this work. So what two numbers multiply to 9 and add to negative 6? Well, that would be a negative 3 and a negative 3. And you can check that both of these work. If I multiply them together, I get 9. If I add them together, I get negative 6. So we'd have minus 3 minus 3. And then just like up above, we can set those two pieces equal to 0. Now notice it's the exact same factor, so I don't need to do it twice. Just doing it once will work. Okay, so just one solution, which we did, I believe, in 4.1 or 4.2. We talked about how there are situations where you might only have one solution. Okay, this one. If you remember, I mentioned up here that you have to get 0 on one side. So if you're presented with an equation like this, where you don't have 0 on the side, that's step 1. Step 1 would be to get 0 on the other side. Okay, so that's what we just did. Now it's written as y squared minus 36 equals 0. Okay, so there's no middle term here. No middle term at all. So let's write down the way this is going to work. I know I'm going to have y here and y here. Exactly the same reasoning as I had up above. When I'm doing my foiling, y squared is only achieved by multiplying y times y. Okay, so then if I look, this is my constant. So when I multiply these two numbers together, I'm supposed to end up with a negative 36. But then when I add them together, I must get 0 because there is no middle term here. Okay, so my product is negative 36 and my sum is 0. So what two numbers would multiply to a negative 36 and add to 0? That would be negative 6 and positive 6. Okay, so I have a minus 6 here, I have a plus 6 here. This is a special factoring pattern called difference of squares. You guys might remember this one. Again, difference of squares. So y squared is a perfect square, 36 is a perfect square. So the pattern just goes y minus 6, y plus 6. So it's always y minus, y plus. That's the difference of perfect squares. So to solve, I'm going to set my two pieces equal to 0. Okay, add 6 to both sides. So positive 6 is one of my answers. And then negative 6 is the other answer. Okay, so let's look at some more examples. Okay, so this gets a little complicated. As soon as I throw something in front of the A, like I said, things are going to get a little bit complicated. So we're going to write a step-by-step here. All right, so step-by-step works like this. We've got A, x squared, B, C. So A is in front of the x squared, C is the constant. You start by multiplying A times C. Okay, so that's your first step. So you multiply the outside terms together. And you only really have to do this if there's an A. We can do the way that I just did on this previous page if there is no A. Next, we do that whole sum and product thing that I was writing on the previous page. So we know we have to find two numbers, just like I was doing on the previous page. Whose product is A times C, whatever that turns out to be, and sum is B. Okay, so find two numbers whose product is A times C and their sum is B. Okay, so we got that part. Now we are going to expand the middle term with these values, and you'll see what that means when we do an example. So this step is like uncombining like terms. And like I said, you'll see what I mean when I do an example. And then last, number 4, we factor by grouping. And so we will recap how to do that. Okay, so those are your 4 steps. So part A and part B, we don't have to do this technique quite yet. We can do the same technique we did on the front because it's just an x squared. If it's just an x squared, I know that I'm starting my factoring with x times x, but we're not that lucky when we get down to examples like C and D. And then don't forget my equals 0. So I look at this term right here. I know that whatever these two numbers are, they have to multiply and give me negative 15. And then I know when I add my outside inside together, I'm supposed to get negative 2. Okay, so this is all just kind of a guessing game. So you have to have like a really good number sense to figure these out quickly. So you're trying to find two numbers that multiply to a negative 15. So first of all, one trick to keep in mind, if you're multiplying to something that's negative, you're going to have one negative number, one positive number. And then in this case, if you're adding to something negative, that means the negative number is the bigger number. So these numbers are negative 5 and positive 3. And you can always check these two qualities. They do multiply to negative 15. They do add to negative 2. So we have minus 5 plus 3. It's really easy to check to see if you're right also, because you could just refoil this left-hand side out and you should end up with this. But now we do our zero product property. I set both my factors equal to 0, and that's how I solve. Okay, so this one, I'm going to add 5 to both sides. And here I'll subtract 3. Okay, so let's do this one really similarly. Since it's just an x squared, I'm lucky enough to know it's just going to be x and x. And then let's look at our other two pieces. So when I multiply these numbers together, I know I should get negative 21. And then when I add these two terms, I should get negative 4. Okay. So what multiplies to a negative 21 and adds to a negative 4? Same rules apply up here. We're going to have one positive, one negative, and I know the bigger one will be the negative one. And it turns out to be negative 7 and positive 3. And again, you could always check that those qualities hold. So minus 7 plus 3. I think we can probably do these in our heads at this point. Here we're going to add 7 to both sides, and we get positive 7. Here we're going to subtract 3 from both sides, and we get negative 3. Okay, so now let's move into these examples where we've got a number out front. First of all, always look to see if there's a GCF. Unfortunately, here there's nothing that 15, negative 8, and 1 have in common. So let's run through our steps. Step 1, multiply A times C. Okay, so A times C is 15 times 1, which of course is just 15. Then we go back to doing the same thing, or really similar to right here. We find two numbers whose product is A times C, and sum is B. So we're looking for numbers whose product is 15 and whose sum is negative 8. Okay, so to multiply to a positive, they're either two positives or two negatives. And in this case, the fact that they add to a negative number means they're both negative. So 15, we're going to use negative 5 and negative 3. They multiply to a positive 15, they add to a negative 8. Step 3 is I expand the middle term, the bx term, with these values. So here's what that means. We're going to rewrite this. It's like uncombining like terms. So I keep the 15x squared. We're going to expand this middle term using these two values. So instead of negative 8x, I'm going to write it as minus 5x minus 3x, and then finish off with the plus 1 equals 0. It does not matter what order you put those two in. I can promise you that. Okay, and then step 4 is we're going to factor by grouping. So in case we're a little rusty on this, here's how it goes. We group these two together, and we group these two together, and then we do the GCF method on both groups. So here we look just at these two terms and see if they have anything in common. They both have a 5, and they both have one copy of x. So that means that 5x is my GCF, and remember I leave that open set of parentheses to plug in the leftovers. So when I divide out a 5x, I'm left with a 3x right here. And then here when I divide out a 5x, I'm left technically with a negative 1. Don't forget about that. Okay, now my next term here, negative 3x and positive 1, they don't have anything in common besides plus or minus 1. In this case, I actually do need to factor out the negative 1, because what will happen is my middle term will end up matching here. So when I factor out a negative 1, this leaves me with a positive 3x, and this leaves me with minus 1. And now if you notice, this part is super, super important. The part in parentheses is supposed to match. Okay, so now the way I factor goes like this. This is technically one big term, and this is technically one big term. They both have this in common, so I can factor it out. So it's just like factoring out a GCF that you did before, and then you leave the leftovers in parentheses. So once I factor out this GCF, what I have left is 5x minus 1. Okay, so that is my factorization. Once you've got that set, then you can set each piece equal to 0, just like we've been doing. Okay, and then just a couple algebra moves. This one we're going to add 1 to both sides, and then divide both sides by 3. Okay, so there's one answer. Same steps here. We add 1 to both sides, and then divide both sides by 5. Okay, so we get 1/3, 1/5. Remember, you could always use your calculator to check any of these answers. Okay, another one of these here. Check for GCF first, every time, but 5, 34, and 24 don't have anything in common. So step 1 is we multiply a times c. So we multiply 5 times 24. If at any point you need a calculator for some of these things, that is totally, totally fine. Okay, so like 5 times 24, for instance, you could plug that in and find that you get 120. Next step is we want to find two numbers. Their product should be whatever AC is, so here 120. And then they're supposed to add to this middle number here, which is 34. Okay, so you might need to play around with some values there. The bigger they get, the more useful your calculator might be. So we can try some different values. Try dividing out a couple of different things. So I'm just trying to divide like 120 by 12, so 12 times 10, but that doesn't add to 34. 20 times 6, but that doesn't add to 34. Let's try 24. I'm getting closer, but 24 times 5 still doesn't add. 120 divided by 25. Nope, not even divisible. 30. There we go. Okay, 30 times 4. So 30 times 4 multiplies to 120 and adds to 34. Okay, so step 3 is we use these to expand our middle term right here. And it does not matter what order those go in. So just like I said before, it's like uncombining like terms. So now we group. We're going to group these two together, and then factor out a GCF. So between these two terms, they're both multiples of 5, and they both have an x. And then in parentheses, you write your leftovers. So when I divide out a 5x here, I'm left with just an x. And when I divide out a 5x here, I'm left with just a 6. Okay, now same technique over here. 4 and 24 both have a 4 in common. There's no common x because this one doesn't have one. So same thing, in parentheses, I'm going to write my leftovers. When I divide a 4 out of 4x, I just have an x. And when I divide a 4 out of 24, I have a 6. So just like I said with the last example, this is exactly what should happen in this step. You should have the exact same thing in parentheses. All right, so remember, technically this is one term and this is one term, They have an x plus 6 in common, so I'm going to factor it out just like I would a GCF. And when I factor out my GCF, that's what I have left, the 5x plus 4. So that is like the leftovers that you write in parentheses. Okay, so now we're factored, so we're going to take each piece and set it equal to 0. Okay, so subtract 6 for this one. And we get negative 6 is one of our answers. Here are a couple moves. Start by subtracting 4. Okay, and then divide both sides by 5. These cancel. So last piece here, we get a negative 4/5.